polysaccharides are starch and glycogen. And we're going to talk about what starches are and what glycogen is when we do your notes. But you're going to see the structure of starch and the structure of glycogen are really, really, really super long, thousands of molecules of glucose glued together. Anybody have any questions on the vocabulary? Anybody need more time with this? Okay. I'm going to go ahead and hand out the 3.2 note. We're going to finish up the rest of that vocabulary when we talk about proteins, and then again when we talk about lipids. So hang on to that piece of paper because we're going to add to it as we talk about the rest of the biomolecules. Might help you when we're going over some of the notes for carbohydrates. This first packet that I'm handing you is basically an overview of all the molecules of life. We talked about carbohydrates, lipids, nucleic acids, and proteins. So I'm going to hand out another worksheet that's going to accompany the carbohydrate section. So you're basically going to be taking notes on both of the study guides. If you think back to your concept map, which we reviewed at the beginning of the class, what did we say carbohydrates were made of? Organic compounds that had what three elements in them? From your concept map. Anybody remember? Ben?
Carbon, oxygen, and hydrogen.
Exactly. Carbon, oxygen, and hydrogen. So carbohydrates are basically organic compounds that are made up of carbon, hydrogen, and oxygen atoms. The numbers of these atoms can vary from one carbohydrate to another. So the number of carbon atoms varies in different types of carbohydrates. Some carbohydrates, like I said when we did the vocabulary, serve as a source of energy. Another type of carbohydrate actually serves as a structural material. If you think about a blade of grass, if you ever looked closely at a blade of grass, you see all the little lines going down the blade of grass? What those little lines are made up of is cellulose, and we're going to talk about what that is in a little bit. Anybody need more time with this one? Okay, a saccharide is a sugar. A monosaccharide, more specifically, is a simple sugar or a monomer of a carbohydrate. Sometimes you'll also see monosaccharides referred to as simple carbohydrates. Like we said in our vocabulary, you'll see the ratio of carbon to hydrogen to oxygen atoms in a 1 to 2 to 1 ratio. molecule glucose. Same thing with this structure. This is ribose, and we're going to talk about that in a little bit. You can see 5 times 1 is 5, times 2 equals 10, times 1 equals 5. So there's your 1 to 2 to 1 ratio. I just wanted you to all see where that came from. This N, this just represents the generic carbohydrate. The C1H2O1 in parentheses with an N after it. This N can be any whole number from 3 to 8. So say, for example, if we had the 6 here for carbon, for glucose, 6 times 1, 6 times 2, and 6 times 1 again. So that N represents any number from 3 to 8. Everybody understand that? Anybody need more time for this plot? Some examples of monosaccharides, and this is still on your white 3.2 notes, are fructose, glucose, and galactose. You'll notice all 3 of those molecules have the same molecular formula, C6H12O6. However, their structural formulas are different. Fructose is the kind of sugar that's found in fruit. That's what makes apples and oranges and bananas so sweet, because of the fructose that's in them. Glucose that we've been talking about, we said is an energy for cells. Galactose is a sugar found in milk. I'm not sure if anyone here is lactose intolerant. Lactose is also a sugar that's found in milk. If you are lactose intolerant, your body cannot break down that sugar. So your mom or dad will buy things for you that are lactose-free, like lactose-free milk or lactose-free cheese. On your yellow sheet, on the top, isomers. Isomers have the same molecular formula, different structural formulas. That is also on your pre-lab. That is the one question people are struggling with on your pre-lab.